Welcome to this channel. In this tutorial, we will simulate the half adder using the Modelsim tool. Before going into this tutorial, I request you to like, share and subscribe to my channel below. In Modelsim, the basic simulation flow is shown below. Creating a working library, compile the design file, load and run the simulation, and then debug the result. In Modelsim, all the designs are compiled into a library. So the first step is to create the working library. Go to File, click on Change Directory. You can create your design folder. So you must create working library directory. So select the working library directory as work1 folder. Now let us create the library work1. So go to File, click on New, select the library, and now in my case I had already defined a, a previous library called as work. So we will define in this as work1. You can keep it as work. So we will create the library work1. You can see that the new work library has been created. Now we have to create a new project called as half adder. Now click on File and select New and select Project. Now a Create Project pop-up box appears and define the project name as half adder, and in my case it is work1 library. So if it is work, then you have to define the default library as work. Now copy the library mapping and click OK. Now you would get this particular project folder where we have to create a new file and define the file name as half adder and add the file type as VHDL. If it is Verilog, then you have to select Verilog. Now double click on this and we will start writing our VHDL code. Now we will write this particular VHDL program in the data flow description. The system's signal flow from input to output. Usually description is done by writing the Boolean function of outputs. So refer to this VHDL data flow description of half adder. The entity declares the input and output signals of the system and is given a name or identifier. In this example, it is half adder. The name of entity should always start with an alphabetical letter and can include special character. Declarations include the name and type of inputs and outputs of the system. Inputs are called as input ports and output is called as output ports. The name A and B are the in bit, or also known as the input bit, is user selected, and S and C as out bit is also user selected. Entity is a predefined word and name of entity is half adder. Port is also predefined. The name of input port A and B must be followed by a semicolon. The type of this input signal is bit. Type bit allows signal to either take logical 0 or logical 1 or type standard logic. In the end, we have to type end and the entity half adder in order to end this entity. Next, we have to define the architecture that includes the details about the relationship between the input and output of the system and must be bound to an entity. The architecture is declared by a predefined word called as architecture followed by the user selected name. In this example, the name of architecture is HA underscore DTF1 followed by the predefined word of and by the name of the entity. The predefined word of binds the architecture HA underscore DTF1 to the entity half adder. The architecture HA underscore DTF1 recognizes the information which is declared in the entity, such as the name and type of ports. The architecture body starts with predefined word begin, followed by detailed relationship between the outputs and inputs. The XOR and AND are the logical operators that simulate the exclusive OR and the AND logic. S defines the sum and C defines the carry of a half adder. The architecture is closed by predefined word end. Now, once the particular VHDL code is complete, click on Save. Now, there is a question mark which defines the status. Right click on that and select Compile the selection. The tick mark indicates that the compilation is successful. Now, go back to the library in work library. You can see the half adder program. Right click on half adder and click on simulate. Again, right click on half adder on structure window and select add wave. The wave window appears on this particular simulation. Now we have to run the simulation. To define the input for this particular simulation, right click on the input and define the value as 0. Similarly, define the value for signal B as 1 and click OK. Now run this particular simulation. We had defined 0 and 1 and because of this the sum value will be 1 and the carry will be 0. Now let us change the value of input A to 1. So right click on A and define the value as 1. Now run the simulation. Now you can see when both the inputs are logic 1, then the sum is equal to 0 and carry is equal to 1. Now let us change the input B to 0 and run this particular simulation. Since one of the input is low, the sum is equal to 1 and carry is equal to 0. Now let us change both the inputs to 0. You can see that sum and carry is equal to 0. Now again let us change the value to 1 where both the inputs are high. Now run the simulation. You can see sum is equal to 0 and carry is equal to 1. Thank you for watching this tutorial. I hope this has helped your learning purpose. I request you to like, share and subscribe my channel below.